Today I want to talk about this problem, minimum cost to divide array into subarrays on recommendation of someone in the comments. So let's just go through the problem statement once. It's very convoluted, but we can try to simplify it. You are given two integer arrays, nums and costs of the same size and an integer k. You can divide nums into subarrays. The cost of the ith subarray consisting of elements nums L to R is so sum prefix sum from 0 to R plus k into I into cost of L to cost of R. And I in this case is the division, subarray division. So the first segment, the first subarray will be I will be 1 and so on. So that's the order of the subarray, right? Uh, so just going through first sample case, nums 314 cos 466 k equal to 1. So in this case, they are saying if you divide the subarray, if you divide the whole nums array into two subarrays, 3, 1, and 4, you'll get the minimum cost, right? Which is 110. So one point to note is you can't really miss any element in between. It's not just arbitrary uh, like subarrays from here and there. It's like it's all inclusive. So every element is included in some subarray that you have chosen, right? And just looking through the constraints, so length of nums in cost is 1000, less than 1000, between 1 and 1000. Value is again between 1 and 1000 for both nums and cost, and k is uh, from 1 to 1000. Okay, so let's, it's asking minimum total cost possible, right? So the first thing that comes to mind is dynamic programming. Now, there is a slight trick in this question. Let's try to work this whole thing out. Second. Okay. So this is your cost, right? For any division, any subarray division that you make, you create a segment. So this will be its cost. Now, without any trickery involved, how would you go about solving this? So you need at least, suppose I have a function solve. I'm trying to recursively solve it. Um, I have a start, I have an end, and I have the order, right? This is how you would go about this. And again, this is kind of a take, not take question. So at any point when you're traversing the whole array, uh, let's just call this pause because I'm more used to that. Yeah. So start, pause. Pause is the current element you're at. Start is supposing when did you start this particular subarray? Like, so if you start the first subarray will have start position as 0, right? And you can choose to end it any time during your traversal of the array. So these are the three things you needed. At any point, you either end it or you continue building it, right? Now, if you choose, let's think about this ready to end case. Uh, the cost of this would be nums 0 till nums pause. So you're ending it here, right? So you have to like first this term, which is the prefix sum of the whole array, plus k into the order. So I'm saying this is the order. Let's just call it order. K into order. So you'd call your recursive function with solve. You start at 0. The current is also 0. And the order is 1. So this is the first subarray, right? This is how you'd call this recursive function. Now, into cost of start till cost of pause, right? This is some current cost of ending it here. And then you have to, so the case one would be, which is when you end the array at that position, subarray at that position and start a new one, it's current plus solve for start plus one. So you move on to the next start of the element should be the next element. So you ended at some position pause. So the next, sorry, not start plus one, it should be pause plus one. So you'd start the new array one element to the right, and the position is also pause plus one. So that's where you are while traversing, and the order has increased by one, right? The next case, or you can say not take in this case is do not end here, would be case two, which would just be solve. Uh, you keep the start same, so you haven't ended it, but the current that you'll be processing will be pause plus one, and order remains the same, right? In the end, you gotta return min of case one and case two, right? Uh, Base case is pretty simple. So let's just write the base case also. So the base case would be once you're at the end element. So when pause equal to n minus one, where n is the length of the array, nums array, you're at the last index. In that case, there is no other option other than ending it, right? So you'd return this part. So when you're at the end index, you just return, assuming you had to end the subarray there, right? Whatever the order it was, you got to use this formula and return it. Okay. Now, certain modifications here or optimizations. So this part can easily be calculated with a prefix nums array, right? So you have to make it O of one, you would just return prenums of pause. So you've calculated the prefix sum of the nums array, you didn't return this. This part again, it's just uh, prefix sum array of cost array, where pause minus precost of start minus one, right? So this you made O of one modifications here instead of O of n, right? But will this pass? Looking at the constraints, you'll have 10 by 3 states here, 10 by 3 states here. And imagine you're segregating the nums array into uh, like the length of num subarrays. So each element in itself is the subarray that you're like trying to find. So this will also be 10 power 3, totally giving you 10 power 9 operations. So this won't work, right? So now you need to find a trick with this formula that they've given and somehow at least reduce one of these, like remove one of these parameters. So what we're going to do is we're going to get rid of this order, making it 10 power 6 possible with the like caching, right? So how are we going to do that? Okay. So the first segment or the first subarray, the cost of like the first subarray is how much? So suppose you end the first subarray at some index R1, right? So it'll be nums of R1, nums of 0 plus so on till nums of R1, right? Plus k into I. Now I in this case, this is the first subarray, so the order is 1. So it's just plus k into cost of 0 plus so on till cost of R1, right? So this is the cost of first subarray. I'm going to write it differently now. I'm just going to say from 0 to R1, it's the summation of nums array plus k into summation of cost array from 0 to R1, right? This makes sense, right? So just look at the second subarray segment now. Okay, assuming we have ended the first subarray, the second subarray's cost, like when you end it, is gonna be 0. Suppose you end it at R2. 0 to R2 nums. You have to notice like this is the just the prefix. So in this case, it's the range sum. In this case, it's the prefix. So it starts from 0 to R every time. So if you end an array at R, subarray at R, the total cost will be from num0 to nums R plus k into I, and then cost of that range, summation of that range. In this case, it'll be 2k. So I in this case is 2. So if you see here, it's k into I. In this case, it's the second subarray. So this I is 2. The order is 2. And you gotta summate from, do the summation from R1 plus 1. So wherever you ended the previous subarray to wherever you ended the current subarray, right? Makes sense, right? So uh, keep going like this. Third subarray will be, suppose you end it at R3, 0 to R3 nums plus 3k into R2 plus 1 till R3 cost. So on till when you made your final subarray. Like that's the last subarray that you have like divided the nums array into. So that's 0 to what? Um, n minus 1, which ends at the last one. Nums plus, suppose you made I subarrays, right? You divided the nums array into I subarrays. This one would be some RJ. Suppose previous one ended at RJ, so this would start from RJ plus 1 to n minus 1 and cost. Now, what I'm going to do is take these terms, the first term and the multiplicative term, in each of these summations. So our answer is basically, so this was cost 1, cost 2, cost 3, and so on till cost I. So what we're looking for is minimum value of C1 plus C2 till Ci, right? So try doing the summation now. Um, multiply this term and this term and this term. You'd get 0 to R1 nums into 0 to R1 cost plus again this term and this term. 0 to R2 nums into R1 plus 1 till R2 cost, right? So on till you get this term. Now, okay, till now we haven't used this I, the order, right? So this is still not complete. So this is our, let's say, answer S. Now multiply this and this. K into cos 0 to R1 plus 2k into 2k into this R1 plus 1 till R2 cost, so on till IK and RJ plus 1 and minus 1 cost, right? So remember what our motive is right now. From our formula, from this part, when we're calculating this current, when we're deciding to end the subarray at some point, we are in need of this order, right? Which we want to get rid of so we can at least reduce this recursion, this DP operation states to 10 power 6 instead of 10 power 9. Right. So I'll write this part of the formula in a different form. So I'll take K outside, R1 cost plus 2 into R1 plus 1 till R2 cost plus so on till I into Rj plus 1 till n minus 1 cost. So if you see the later ranges, the cost is increasing by 1. So this had just one contribution, right? This has two. The next one will have three contributions, R2 plus 1 till R3 and cost, and so on. So it's increasing. So I'm going to do one thing. I'm going to try to write this part down again in a different way. I'm going to write 0 to R1. So this term from here. Then I'll take one term from this. Like there are two R1 to R1 plus 1 to R2 cost summations. I'll take one of them now. So it'll be like R1 plus R2 cost. Again, I'll take, so now the leftover elements in this, like contributions, are just this R1 plus 1, R2 cost. Because I've taken, so this is just, okay, I'm explaining some basic stuff, but this is just two of this is this plus this again. So I've taken one of them here. Same thing, I'll take out of three of these, I'll take one again outside. I'll take one again right now. So this is R21 plus R3 and cost, right? So on, I'll keep taking it till this part, Rj plus 1, n minus 1 cost. Okay. Now there's some other part also here, right? Which I'll talk about again in some time. But if you notice, this is nothing but summation of 0 to n minus 1 cost, right? It's exclusive ranges comprising of all the ranges and costs. So this part of the formula is just this 0 to n minus 1. All elements in cost should be like used in the summation. And this is one part. Okay. Now, what is left? This dot is nothing but, now I told you I've used one of this in this, right? So there's one more left. I'm going to repeat the same process again, but starting from R1 plus 1 to R2 cost. So instead of it starting from 0, it's starting from R1 plus 1 to R2, and then R2 plus 1. So taking one, so there were three like values of this R2 plus 1 till R3 summations. I've taken one earlier here, the two more left. So I take one here, it's cost R3, and so on till the end. I take one again from that, Rj plus 1, n minus 1 cost. So again, if you notice, this part is nothing but R1 plus 1 till n minus 1 cost, right? And what is R1 plus 1? It's nothing but where my second subarray started from. So doing this for everything, I'll end up with a formula something like this. So um, let me write it down again. This part stays the same. right? And then I have k into the start of the first subarray till n minus 1. The range is 0 to n minus 1 of cost. The second term is start of this second subarray till the end, its summation, and so on. For I terms, it's just rj plus 1 till n minus 1 cost. So now what I'm going to say is there are same number of elements in this part as there are in this. So like I'm considering this as one element, this as second. So for each of them, there's one for each subarray. So what I'm going to say, instead of the formula using order, I'm just going to say the cost of one subarray is basically 0 to its end, like wherever you ended it, nums cost, right? Uh, then L to R, wherever you started it and wherever you ended it, that range, all the summation of in that range, plus K into from start or from L to n minus 1 of cost. So now if you look in this, I don't have any dependency on order, right? So it's just a different way of how you're writing that formula and what you can find out from when you do summation of all subarray costs in the end, you'll end up with something like this, right? And I'm distributing how these like summations are used into each part of the subarray. So instead of saying it's this k into I order, using order as one of the contributions in my costs, subarray costs, I have removed it and I've said like each subarray's cost is just this term and then k into from wherever that subarray started to n minus 1, like the whole range, the suffix of cost, right? So now, once I don't have dependency on order, my solution is of has 10 power 6 states, which can be cached and then used uh, in the solution. Okay, so let's try to code it right now. Okay, so I'm gonna need some prefix sum arrays first of all, long pre-cost and pre-nums. Okay, I'm gonna need a DP array. Okay, I can come back to DP later, but so n equal to nums length. Pre-cost is nothing but um, of the same size as my nums array. Same with pre-nums, right? Pre-cost of 0 is cost of 0. Pre-nums of 0 is nums 0. And then I just pre-process these and calculate all the values of pre-cost and pre-nums. So pre-cost of I is nothing but cost of I plus pre-cost I minus 1. Similarly, so this is just pre-computation, pre-processing. I'm calculating the cost arrays to find some ranges, range sums. Nums I plus pre-nums I minus 1, right? Okay, so now I'll write a recursive function which takes in nums, cost, starting position, which is 0, uh, or like the current element that we're processing, which is 0. This is pause value. like the start of the subarray, like where did this existing subarray start from, and then the k value. So this is solved. Uh, Nums is needed, cost is needed, pause is needed, start, where did this start, and then k value, right? Let's come to the base case later. Now I'll write two cases, which is end here in the subarray at this point, and don't end here. So keep on dragging this subarray for later, giving you lesser number of divisions. Okay. So suppose you ended it here. What did we discuss? So our thing got broken down into two parts. Let me show it again once. So now each subarray's cost is 0 to R, the position you're ending it at of nums, and then L to R of cost, summation in that range, plus K into summation of cost from start till the end, the suffix, right? So this is what we got here. So if you decide to end the subarray here at R, this is the cost associated that will be added to your like ending cost. Okay, so when I decide to end here, I'm just going to calculate this current cost, which is pre-nums summation of nums array till the current position. So you're ending at pause into subarray cost of that range. So it started from the start value and ended at pause. So what you need is, I'm just going to write subarray cost here. Okay, so from start till pause. So from L, which is start, to R, which is pause. Okay, and current will be added with K into the second term that we discussed. So subarray cost, which is the suffix of cost. So we need to calculate from start to n minus 1 till the end, right? So now my end case is my total cost doing this, ending it here, is current plus solve for nums cost. So now the next element is pause plus 1, and it should start from that element. So you have changed the start value also, right? And k. So this is my ending here. And what if I don't end it at this element and continue it? So I'll just call it don't. Nothing gets added, and you solve for nums cost. You move to the next element, but start remains the same because you haven't ended it, and k. And you gotta return math min of what? End and don't, right? So this is it. Now for the base case, once your position, the index that you are processing has reached the last index, what do? You just calculate this part again and return it, right? Because this, there is no further processing to be done, and your whatever subarray you're on should end here. Wherever it started from, it ends here. So prenums of pause into subarray cost from start to pause, which is n minus 1, pause is n minus 1, and you return current plus k into subarray cost start to n minus 1, right? Yeah, so this is it. Now we'll cache it, but we have to write this subarray cost function first, int L and int R. So Long left, if L is 0, then you subtract 0 from it, otherwise you subtract L minus 1. And long right is just precast R, and you return right minus left. Yeah, so this is it. And let me see. Oh, this is a huge case. This should work for at least smaller values. Yeah. Now to cache it, it's pretty simple. You have a long 2D long array, which is of n and n dimensions, right? So if dp of pause and start is not minus 1, you return dp pause start, otherwise you cache it. And you return it, and what else? Am I missing something? Okay. So for I'm gonna initialize all the values with minus 1. Okay. What is going on? Lang. Oh, sorry about that. It should work if I haven't made any stupid mistake. Yeah. So yeah, this is it. Thank you.